Okay, let's discuss a new vulnerability called XML or XPath injection. And to demonstrate this, I want you to navigate to your Bebop application. Under here, we want to scroll a little bit down and find this right here. As it says, XML XPath injection. Let's click on this one first, which is search for. So let's click on that, click on hack, and it will load this application right here. Now, this vulnerability is kind of similar to SQL injection. The input that we send could be processed unfiltered through XPath. Now, since we don't really have any input right here that we can type in, we can assume that this button is our input. So we can select the movie genre, action, horror, and science fiction. If we go with science fiction and click on search, it will output all the science fiction movies. Okay. Now, let's try intercepting this request with Burp Suite. Let's go right here. Let's turn on the intercept and let's click on search. So we can see our parameters are getting sent through this link. We get genre to be action and action equals search. Now, let's try a simple injection type. Let's try to see whether we can get error by specifying a single quote, the same way that we did with our SQL injection. So let's type action, single quote, and let's forward this packet. Let's go back here, and we do get some error. We get warning, simple XML element, XPath, invalid expression. Now, there is one thing that this application can do. We can check whether it requires entire name of genre, which is action, or can it determine which genre it is with just a first few letters from the name. For example, if we type ACT, can it determine that we want the action genre? Let's give it a try by intercepting the request once again. And instead of sending action, let's delete last 3 letters and just leave it on act. If we forward this, go back, it does actually load the action movies. So it can determine that we meant to search for action movies just by looking at first 3 letters that we specified from the genre name. Now, why did we check for this? Well, if we still get results like that, this could mean that the application uses a function called contains. And that function looks something like this. Let me just nano example.txt. This is the function that our application could possibly use. And since we're testing this as a black box, we won't be looking at the source code, but we can assume that the code to the application could look something like this. Open square brackets, contains, open normal brackets, genre, comma, and then single quote, $, and something like genre input. It doesn't have to be called like this, but let's just assume that the application could have a code that looks something like this. So, if the genre input is contained in the genre name, then it will just load that genre. So, let's also use this contains function ourselves to try to get everything outputted that the application offers. And to do that, we need to craft our payload. Since we assume that the application could potentially use a function like this, we need to escape it first. And we're going to escape it with closing off our brackets first and our single quote to our input. So we start like this. This is our first 3 characters. And then we must use this syntax, which is slash and then $, then pipe. Since we're piping another command, we use slash and again $, and now we use our own contains function, which we can access by opening square brackets and then contains. Then let's open normal brackets and specify 1, 1 inside of the single quotes. And the last single quote we're not specifying due to the same reasons as in the SQL injection. It's probably already specified inside of the application at the end of our genre input. So what we did right here is we pretty much closed off this code in the application by specifying these three signs. Then we added our own contains function, and the leftover signs that we closed off in the application code are getting added at the end right here, therefore we don't need to type it in twice. If we copy this code and we go and intercept our request once again, we, instead of typing action, we can delete this and specify our code, which is this one right here. If we forward this, go back to the application, here it is. We get all the output right here. You can say the entire database drop, even though it's not a database drop, but we do get all of the movies that are in this application, just by exploiting the contains function and the unfiltered input through this genre tab. Awesome. In the next video, we're going to check another example of XPath injection that we have on Bebop, which will be really similar to SQL injection. Thank you for watching, and I will see you in the next lecture. Okay, let's cover another XPath injection. So let's navigate to our menu where we can choose our bugs, and let's go with the second XML XPath injection that we have available. Click on that and click on hack. So this application has a login form. We need to specify username and password. So let's give it a try. If you remember from the previous video, I mentioned that this will be rather similar to SQL injection attack. So let's go in that direction. Let's first of all specify normal username and password. So I'll specify test and test. Click on login and nothing really happens. Let's go down. It says invalid credentials. But what would happen if I type test, single quote, and test, single quote? Click on login. We do get invalid credentials, but up here we will have a warning or an error. Simple XML element, invalid predicate in this path. So we do get an error. The way that we can exploit this error is pretty much the same way that we exploit SQL injection. So all we have to do is type test or 1 equals 1 with single quotes. And same thing for password or 1 equals 1. We click on login. And here it is. We logged in as user Neo. Welcome Neo, your secret. Oh, why didn't I took that black pill? So we get the username and its secret. But there is more to this than just logging in as this user. We can try to log in as any user in case this application defines users with an ID. For example, Neo could be ID 0. A different user could be ID 1. Another user could be ID 2, and so on and so on. In case there is a parameter or variable ID that reflects on each user, then we can switch the user by changing the ID value. So we can try something like this. Test, single quote, to close off the normal input. And we type or ID equals, for example, 2. Remember not to close the single quote at the end because it's already getting closed by the application. Let's type the same thing as password, so test, single quote, or ID equals 2. Let's go down. And now we are a different user. Welcome Alice, your secret, there's a cure. We can go even more, so ID equals 3. And let's do the same right here. We are Thor now, and you can see where this goes. This application allows us to interact with the ID value, therefore allowing us to switch the username just by selecting test single quote or ID equals 2. And then it logs us in as that user, and we also get their secret. So this was rather easy to exploit. In the next lecture, we're going to take a look at a different type of vulnerability that we haven't encountered before, which is called XXE. See you in the next lecture. Welcome back. Let's discuss a vulnerability called XXE. Now, first of all, what does XXE stand for? It stands for XML Entity Injection. It happens once an application takes the user input in XML format and it processes external entities that are declared inside of it. If that happens, it could be vulnerable to XXE or XML Entity Injection. Let's take a look at the example of this vulnerability on our BWAP application. So let's go to choose our bug, scroll a little bit down till A7, and all the way down we have XML internal entity attacks, or in brackets XXE. Select that and click on hack. This will load this very simple application. There is no user input here, all we have is this reset your secret to any bugs. So this is a button. Let's see what happens once we click it. It appears that nothing really happens. Let's try intercepting this request inside of our burp suite. So go up here, turn on the intercept, and let's click on any bugs. We get this request. And if we take a look at down here, we have the application processing some input in XML format. And remember what that means? If it also processes our external entities that we are going to inject, it could be vulnerable to XXE. But before we actually get to injecting anything, let's first send this request to the repeater. Let's go Action and Send to Repeater. We can turn off the intercept and navigate to the repeater. If we take a closer look, we're going to notice that this request is sending XML structure with our username, so this is our account on BWAP application, and with a secret. So let's try ejecting a simple payload to see whether this is vulnerable to XXE. And the payload that we are going to inject will be this one. I'm just going to type it in payload.txt real quick, and then we're going to copy it to burp suite. So this will be our payload. Doc type test, let's call it test. Then we open square brackets and we create our own entity like this. We type capital entity. Let's call the entity internal dash entity and let's name it boss. So close off all of the tags. And this will be our payload. So essentially what we're doing right here is we're creating an entity called internal entity, which will have a value of boss. And boss will be a new user that we're going to try to switch inside of our payload. Now, how are we going to know whether this works? Well, if we go to our burp suite and we send this simple request, in the response to this request, we get this sentence right here. It says B's secret has been reset. If our payload gets processed inside of this request, then here it will say boss secret has been reset. Let's give it a try. Let's go and copy our payload. Let's put it up here right above the XML code that they have. So let's paste it right here. And this is not the only thing that we must do. We must also change this part right here. Since we want to change the user, we also want to specify which user we want right here. And the user that we want is stored in this internal entity. So all we have to do is specify it right here. To do that, we use this sign, and then we specify the name of our entity, or in our case, internal-entity. And semicolon at the end. once we send this payload, here it is. We get boss secret has been reset. It's no longer the user B. In this payload that we created, this internal entity that has a value of boss is used within the login structure, and it got reflected right here in the response. This means that everything will load through this entity, the server will process and reflect. So let's try with even more dangerous payload. Let's try to cat the content of @c passwd. We can do that by typing this command or this payload doc type. Let's call it test and open square brackets. We want to create entity once again. And we can call it anything we want. We can call it xxe if we want, or we can just stick with internal entity. This is pretty much your choice how you're going to call it. And now we're going to call a parameter called system. Make sure to type it in capital, so capital system, which will take the value between the double quotes of file, column, 3 slashes, and then @c/passwd. This is the file that we want to get the contents from. Let's not forget to close off our tags, like this, and this will be our payload for the xxe. We are using this system parameter. We define it in order to get our external entity to load the file. In our case, the file that we're loading is @c/passwd. If this works correctly, once we load it, the server should show the content of this file in the response to our request. Let's copy this. Go back to our burp suite. Let's delete this. Paste our new payload. And since we called it once again internal entity, there is nothing really to change right here. We can leave it to be internal entity, but if you were to call it differently in your payload, make sure you switch the name right here as well. Awesome. Let's send this. And here it is. We get the output of /@c/passwd file on the target system. And this is xxe vulnerability. Now that we covered that, we're going to take a look at a different type of vulnerability in the next lecture, which is called components with known vulnerabilities. See you there. Okay. Components with known vulnerabilities. This is a really interesting vulnerability because it's a really big one. We're going to take a look at the example of it in our Try Hack Me platform, so just navigate to your OWASP top 10 and you will have it under task 27, 28 and task 29. So what exactly is this vulnerability? Well, applications can run on certain software. And this can be any software from Tomcat to WordPress to using PHP to using different types of databases and all of that. And all of those softwares had some type of vulnerabilities in the previous versions of them. Now, what happens is that many websites and many companies don't regularly update their software. So a good example here is that it says, let's say that a company hasn't updated their version of WordPress for a few years. And using a tool such as VPS-Scan, you find its version 4.6. Some quick research will reveal that WordPress 4.6 is vulnerable to an unauthenticated remote code execution exploit. So many of these softwares, well-known softwares, have known vulnerabilities for previous applications. And this vulnerability occurs once an application is running a software that is outdated and that has a known vulnerability. Now, this is a big topic that doesn't really have anything to do with bug bounty, but we're covering it nonetheless because this is also something that you want to search for. So in this example, I have already started my virtual machine and you can start it on task number 29. The task that we have is how many characters are in /@c/passwd file. We can use this command to determine that. So let's give it a try. Let's copy the IP address of our machine and copy it straight into the browser. Okay, so it opens this application that's called Online CSE Bookstore. And since we already know what type of vulnerability this is, we would actually try to scan it for different technologies that this application runs. What web server it has, what programming languages does it use, and all of that. But particularly, we also want to check out the application name. So for example, this online bookstore could be something that is used widely and that actually has some known vulnerabilities. How can we determine whether it has known vulnerabilities? Well, we can just copy its name and try to find something on Google. Now, make sure that you don't confuse this vulnerability with the vulnerability where we covered with default credentials. Default credentials are something else. That is the mistake of the owner that they didn't really change their default credentials. It's not a software vulnerability. However, this might have a software vulnerability, and by the results that we get, it does indeed have them. We get 2 results or even 3 results right here, but only the first 2 are on famous exploit website, which is called exploit-db.com. On this website, you will have a bunch of different exploits for a bunch of different outdated versions of software. Let's go with this first one first. It's called Online Bookstore, Unauthenticated Remote Code Execution. This is really a serious vulnerability. And how this website works is it gives us the code to the exploit. In this specific example, the code is written in Python. Now, we can download the code by clicking on this button, and what's good for us is that we don't really need to know what exactly this code does, even though that is something that you want to get used to. You want to get used to reading code, and even better would be if you were to learn some programming language, because you will need it sooner or later once you get into this field of ethical hacking and bug bounty. Nonetheless, we're not going to refer to this code that much because programming is not a topic for this course. However, we're going to download this code and run it and see what it does. And that is also another reason why you actually want to learn programming. You don't want to be running any type of exploits on your machine. If you don't know what this code does, then you won't really know what it will do on your machine. It might do something malicious, you never know. Especially when you're downloading exploits from some sketchy site. Nonetheless, this is exploit-database.com, and it should have a working exploit for us. So let's open the folder where we downloaded our Python code, and it's called 47887.py. To run it, we can open terminal in this folder, and we can simply type python3 and then the file name. Hopefully this will give us some help menu that will tell us how exactly can we run this program. In this case, the help menu says, error, the following arguments are required. URL, which is pretty common sense. We need to specify which target are we attacking with this exploit. And in our case, it will be this target. So let's copy the IP address to our online bookstore. And let's go back to our terminal and run our exploit like this. Let's paste the clipboard and press enter. Do you wish to launch a shell here? Let's specify Y for yes. And here it is. We opened a remote command shell, and now we can execute the commands on the target system. If I type who am I, it will give me the result. If I type ls, it will also give me the result, and now I'm pretty much on that machine. I can do whatever I want on it. And this is the power of exploiting outdated version of software. We got the remote code execution vulnerability, and now, to finish it off, let's go right here, let's copy the command that they tell us to run. Let's paste it right here and run it. And the output that we get is 1611. Let's copy that, specify it right here as our answer, and submit. And it's the correct answer. So, you saw how serious this can be. you can be protected by all of these bugs such as SQL injection, such as XSS, HTML injection, XXC, and all the others that we covered, but if you're running outdated software with a known vulnerability, there is most likely going to be a code out there online or an exploit out there online that we can just download and run and get straight into that machine. We pretty much gained access to it in 2 seconds from running this exploit. But even when you find something like this, that's not where you want to stop. There could be other vulnerability as well. For example, we did notice, let me go back, we did notice another link right here that is from ExploitDB. Whoops, I have no idea where I went. Yeah, it's this link right here from ExploitDB, and it could be another exploit. So we want to take a look at that one as well. And this one seems to be an HTTP request. Let's read through it. CSE Bookstore is vulnerable to an authentication bypass vulnerability on the admin panel. By default, the admin panel is located at /admin.php, and the administrator interface can be accessed by unauthorized users exploiting the SQL injection vulnerability. We're already familiar with SQL injection, so let's give it a try. Why not? Even though we found the vulnerability and we finished the task, we still want to discover all the other vulnerabilities. So let's see how can we access the admin panel without actually manually adding /admin, and here's the admin login page. Let's click on that. We get the login screen, so let's try with the basic SQL injection test single quote or 1 = 1 with single quotes, and we use the same thing in the query. Let's submit this. Oops, yeah, we're logging in as admin. We don't really want to use the SQL injection as the name, we only want to use it as the password. So here we're simply going to type single quote space or single quote 1 single quote equals single quote 1. Let's submit the query, and here it is. Our SQL injection worked and we found the second vulnerability, and now we're logged in as admin. How cool is that? We even used knowledge from some previous section to exploit another vulnerability on this page. Cool. Now that we covered this, we're only left to cover one more thing in the next lecture, which is called insufficient logging and monitoring. See you there. Okay, this is the last thing that we have left to cover. Now, this is not necessarily a bug, but it's something that could be useful for you to know. And that is insufficient logging and monitoring. Now, most of the websites and applications and all of that have their own logs. And log is something that is tracking different traffic, perhaps on the website, different HTTP requests, different form submissions, and all of that. It is a good skill to know how to read different logs, and it's rather easy most of the time. So let's take a look at this quick example right here. So if we click on insufficient logging and monitoring, which is task 30, I advise you to read through this to get a better grasp as to what this actually is. And now we're going to download the task files. So there is not a virtual machine that we must start. Here we are downloading files. In this specific case, it is a file login.txt. Let's click on save. And while that is downloading, let's go down to check out what are our challenges. So the first question is, what IP address is the attacker using? And the second question is, what kind of attack is being carried out? Let's go to our file. Let's open it. Double click login.txt and it will open this small logs file. By the first look, I can already see that it is a part of a log file from different users trying to get access on a website at /login directory. So they're most likely trying to log in with username and password. We have 200 code OK for first 6 users, and that means that they successfully logged in to the page. This is most likely their usernames right here, and this is the time when they performed the login request. Here we also have their IP address. So what is off right here? Well, these 401 requests that say unauthorized do look suspicious. Of course, it can be different users that mistyped their passwords, so they got unauthorized error. But we will notice that it's all coming from the same IP address. So all 4 requests are coming from the same IP address with different usernames. This could point to a brute force attack, for example. We can also see that the user is trying to authenticate as the admin, so that is also suspicious. So we can conclude that this user right here is trying to perform a brute force attack, for example. Let's answer the first question. What IP address is the attacker using? So let's copy the IP address like this. Specify it right here, and for some reason it won't copy, so let's just type it 49991316. Let's click on submit, and that is the correct answer. What kind of the attack is being carried out? Well, we already mentioned that it's most likely a brute force attack. So let's specify that right here. Click on submit, and that's also the correct answer. So this was a quick example of how to read logs and how to find something that might look suspicious. Nonetheless, let's move on to the next lecture, where we are going to cover how can we monetize bug bounty skills that we learned throughout this course. Alright, we came towards the end of the course, and now is the time to discuss, well, how can we earn money with the skills that we learned? Is it something that we can monetize, or is it just additional knowledge that we gained? Well, let me tell you. You can monetize bug bounty, and you can monetize it really well depending on how good you get. But before we talk about where and how to do it, let's figure out what the next steps are before we get to earning money with the skills that we learned. Well, picture it like this. This arrow is your path. At the beginning of this arrow is you, a bug bounty hunter that just finished this course. And at the end is you earning money from bug bounty. The only thing that's in between is practice. There is a lot of practice waiting for you to really master this skill. The only way to get comfortable with bug bounty is to perform all the attacks that we covered numerous times on different applications. You might also discover some new vulnerabilities in the meantime that are also useful to know. You can learn more about bug bounty through various different websites, courses, books, and bug bounty programs. Once you do that, you're ready to hunt down your first bug. Okay. Let's say you're ready and you practiced and feel comfortable doing bug hunting. Well, what now? Where can I submit my bugs and earn real money? Okay, have you noticed how I mentioned something called bug bounty program? Well, there is your answer. There are numerous online platforms that host different bug bounty programs that pay real money. How exactly does it work? Well, it's based on different companies applying on the platform for bug bounty programs regarding their website, their application, or software. On the other side, there are hackers that also applied for that same bug bounty program, and their goal is to find the bug on that company's product. First thing they do is accept terms and conditions and rules for that bug bounty program. After that, if they fulfill the requirements, they are allowed to explore for vulnerabilities on that website, for example. If they find the vulnerability, they are then rewarded with a payment which can be different depending on the vulnerability severity. Once the hunter gets paid, the company then patches the vulnerability, and it is no longer vulnerable to that attack. It's simple as that. But listen, there are some important stuff here to mention. Remember when I said that hacker accepts terms and conditions and rules before he enters bug bounty program? Well, these terms and conditions are not something you want to skip like you skip them on every other website. Here, they are really important. For example, in the bug bounty program rules, it could say that certain types of attacks are not allowed, or that certain domains are not for targeting. It could, for example, have a rule that DDoS attacks are not allowed, which is a common bug bounty program rule. If you don't bother reading those rules and you do what you're not supposed to do, like running a DDoS attack, for example, well, then you can get in trouble for doing something that you're not allowed to do. Nonetheless, I'm sure all of you will follow the rules and there will be no problems with that. Now that we covered how earning money with bug bounty works, let's mention a few platforms that are hosting bug bounty programs. We have HackerOne, Bugcrowd, Integrity, Synack, and there are others, of course. But these are one of the most famous ones. Let's go on one of these to see how the web page looks like. Okay, I've chosen to show you Bugcrowd. It's one of the biggest platforms for bug bounty programs, and you can find it at the link of bugcrowd.com, or you can simply just type Bugcrowd in your search bar. Once you do that, let's navigate to their webpage and see what they have to offer and how all of this stuff works. So the first page that it opens will be this one, where you will have this How It Works button. You can click on that and you can read more about bug bounty programs and all of that. Of course, we are not going to go through all of this. You have an explanation how it all works, but that is something I leave up to you to read. Another useful thing that you have and that you will notice in the upper right corner is this researcher portal and customer portal. What is that? Well, you can create an account for two different situations. Either you're a security researcher or a bug bounty hunter, or you're a customer or a company that wants their product to be tested for bugs. That's how you would register accordingly. As a bug bounty hunter, we would go to researcher, and we can also click right here on researchers to read more about that. If we scroll a little bit down, let's see if there is anything interesting here to say. So we have a few different programs: bug bounty, penetration testing, vulnerability disclosure, attack surface management. You can also learn even more and upgrade your skills with different programs, but that is also something that I will leave up to you. Now, let's get to the important stuff, and that is this programs. If you click on programs, it will open this page with all the different bug bounty programs that this platform offers. And you will notice there are some really big companies out here. We have Cash App, we have Upwork, we have, let's go all the way down, Indeed, Jora, and you get some of the information about certain bug bounty programs right here. For example, how much they pay. It says down here managed by Bugcrowd. So let's take a closer look at one of these programs. Let's go with Upwork. Now, Upwork is a big platform. It's a freelance platform. And let's see what do they have to offer us and how exactly does their bug bounty program look like. Remember, there are a few important stuff that we must take a look at before actually applying for any bug bounty program, and that is their terms and conditions and rules. So up here we will get that they're paying up to $5,000 per vulnerability, and it can also go up to $10,000 of maximum reward. Now, you will see later that the actual amount that you get paid is based on the severity of the vulnerability that you found. Let's go all the way down. We have special bonuses and rewards. You would actually want to read through all of this if you were to apply for this program. On the right side, we have how much vulnerabilities are rewarded, so 470, and the average payout was $648. Now, if we go even more down, here is the important stuff: scope and rewards. Here you will have the description of what exactly are you going to, let's say, perform a penetration test on or try to discover bugs. They will tell you which application it is, which domain it is, what you're allowed to do, and up here we also get how much they're willing to pay per vulnerability. And you will notice these signs right here: green P4, orange P3, red P2, and, or is this orange? I'm not really sure. This could be yellow P3, orange P2, and red P1. Now, we'll discuss that in just a second, but let's scroll a little bit more down. And here is also important stuff: out of scope targets. These are the targets that you are not allowed to perform penetration tests on or discover bugs. If you do so, you can get in trouble and you can get removed from the program and not rewarded at all. And that is the easy way out. You can also get sued, but hopefully you will read through all of this information before applying for any bug bounty program. Down here we have ratings and rewards, and we also have requirements. So this is also important to read before applying. They want the user agent to participate in the Upwork bug bounty. Please configure your scanner to include bug crowd in the user agent string. Failure to do so may result in your IP being temporarily blocked from participation in the program. Access Upwork account. You can self-register for an Upwork account and Upwork API using your bugcrowdninja.com email address. Testing using any other account is out of scope. So this is also some important stuff. Down here we have target information, access and credentials, exclusions, and to really understand these vulnerabilities, you can scroll all the way down, and down here you will have program rules. This program does not offer financial or point-based reward for P5, informational findings, which is probably information gathering vulnerability or information disclosure. And here you will have the list of different vulnerabilities and also how they are rated by severity. So here you can take a look at what different vulnerabilities belong to P1 technical severity or the highest severity. So we have SQL injection, XXE, remote command execution, command injection, disclosure of secrets, and many more. You can read through all of these different vulnerabilities to understand what level each vulnerability is. Okay, awesome. And that is pretty much all you need to know to start with bug bounty. Nonetheless, we are at the end of the course. There is a lot of practice still awaiting you to really master this field, which I'm sure you will. Everything else is on you. If you have any additional questions, feel free to ask and we will be more than happy to answer. Thank you for watching and happy hacking.
Hello! That was a little bit excessive, but I'm very, very excited to start the course. So in this section, we're going to be talking about browsing the web. It's the first part in the How the Internet Works section. And some of you are thinking right now, whoa, Andre, like, come on. I know how the internet works. Let's get to the heavy, technical stuff. But this is something that actually took me quite a few years to learn. And I see a lot of people just skimming the surface of this stuff without fully understanding how everything works together. Without having those foundations, it's actually very, very difficult to think about performance, optimizing your site, and so on and so on. So we're going to start off very, very basic, and we're going to learn something that it took me many years to learn. And once I figured this out, everything clicked. So just hang in there. Trust me. I promise you'll learn something new in this section. And we're going to be talking about browsing the web. We have over here a laptop, and we have a web browser, let's say Google Chrome. And we typically like to say, go to Google, and we're going to visit Google. So we type in google.com, and well, what happens technically when we do that? When we enter google.com, we press enter on our keyboard. We ask a question. Who's this Google.com fellow? And that question gets asked all the way down to our ISP. ISP is Internet Service Provider, and I put a $ up here, just so you know those are the people that you pay so you can have internet. So if you're in the States, that's Cogeco, Verizon. If you're in Canada, that would be Bell or Rogers. Or, depending on your country, you have your big companies that make a lot of money from internet usage. So they get that request and they send that off to something called the DNS server, so domain name servers. And we'll get into that later on in the course. So don't worry too much about it, but essentially it's a phone book that has the list of all these URLs like google.com, and it has the addresses of them. So exactly like a phone book, they know where google.com is. So they say, hey, I don't know Mr. Google.com personally, but I do know his address. So you should go check him out. So they send off that request back through the ISP, and the website or the web browser, Google Chrome in this case, gets 172.217.723. All right, cool, but nothing's showing up yet. There's no google.com. I can't do any searches yet. Okay, we received what we call an IP address. So think of this as something that every single computer has one. Anything that's connected to the internet has its own address. So the laptop that I'm working on right now has an IP address. Your laptop or computer has an IP address. So this IP address allows the internet to work essentially. It knows our location, our address. So what we do now with google.com, we know this IP address, the browser sends off another request to the Google servers. And it knows where the Google servers are because we have this address. So we go seek it out. And you can think of servers as computers, essentially. My laptop could be a server. Your computer could be a server. Servers are essentially computers that are sometimes in basements or in huge server farms. And they have a piece of software running that, just like at a restaurant where a server brings you food, it knows how to send you files when you request for them. So we send this off. And the Google servers say, oh, yeah, no problem. Let me give you my HTML, CSS, and JavaScript. And we'll get into what those are later on in the course. But think of them as just text files. They're text files that Google is going to send to the browser so we can have Google working. So let me just minimize this and show you what it's doing. So we're copying these files. And Google server is saying, yeah, no problem. Thanks for asking for Google, here it is. And the web browser receives the HTML, CSS, and JavaScript. So if we go to the next section, boom, we have google.com and everything's working. Now, that sounded like a whole bunch of stuff that happened in between. And when we're on the internet, everything is quite fast. But yeah, underneath the hood, all of that is happening. And it's crazy to think how fast everything works. Don't take my word for it. Let's just check this process that I'm not just making stuff up for you. If what we learned was correct, technically, we can skip this process, right? I mean, if we know the address of Google, can we just, go into this directly and just, instead of putting in google.com, just put in this in our search bar and it automatically goes to the Google servers? Well, let's try it out. Let's open up Google here. And, ooh, what a pretty picture. All right, so we go to google.com. Nothing crazy here. And that's great. But what if instead of that, I put in the IP address? So 172, there's no way I could remember this address. So I've done this before. And I press enter. Look at that, google.com. So as you can see, I'm not lying. That's what's happening. The IP address gets sent to the Google servers. Google servers send us a few files so that we can finally load google.com. In the next section, we're going to do something fun. We're going to break a bit of Google and toy around with the website again to show you how cool all of this technology is. See you in the next one. Bye-bye. Welcome back. In the last section, we talked about how we have google.com, and if we enter an IP address, we essentially get all these files from Google. So if we look back at the diagram that we had, we see here that the Google servers just send us a couple of files, which are HTML, CSS, and JavaScript. Again, something that we'll cover later on. But for now, based on that knowledge, we should be able to break Google. So let's play with something. If you open up Google Chrome and you go into View, then Developer, then Developer Tools, you're going to have a screen over here that pops up. You might want to move it up and down just so you can see better. Let me just scroll this down a bit so you can see. You'll see over here that there's a little icon on the left with a pointer and a window. If you click on that and now go to the website, you'll see it selects a bunch of different things. So it's just an element selector. So let's just click on this. So when I click on this, it takes me to the part of the HTML file that essentially tells Google to put in Google search here. So based on that, we can do something fun. We can get the value over here of Google search and let's change it to Andre search. Press enter. Look at that. We now just changed Google to have Andre search over here. That's very, very cool. I want you to play around with that and see what you can do. For example, if I now select this and I'm just like, I don't want this, I'm going to press the delete key and just delete it. Look at that. I can delete that. Okay, I don't like that either. I'm going to press delete on that as well. And let's see. You know what? I want the entire website. I want this entire body thing gone. Delete. Look at that. We just completely deleted Google. Now, you must be freaking out. What happened? Am I going to get sent to jail? I just deleted Google. Well, no, not really. Press enter and Google is back. Now, why is that? Well, if we go back to our diagram, we have Google servers and we were playing around with one of these files and we just modified it. We essentially just said delete, delete. So Google was gone. But when I made that request again, Google servers, no problem. We have these files. They send these files all over again back to the server. Hopefully that made sense to you. We see that the browser essentially is a tool, a piece of software that can receive files from servers and it knows how to read them so that, look at that, we get pretty Google and we can type in all the searches that we want in the world. All right, let's get to the next section where we talk about the internet backbone. See you in the next one. Bye-bye. Hey there, welcome back. All right, if you thought so far everything's been really, really cool, well, things are going to get a lot cooler. We're going to be talking about the internet backbone. So we recognize this because I've been talking about it for the last couple of lessons. But some of you may have had a question that is, what do the arrows mean? I mean, it's kind of like magic, right? I just told you that we send off the IP address to the servers. The server responds with some files, but this is just magic. Like, what do these arrows mean? So we're going to talk about that in this lesson. And we're going to do that with this really, really fuzzy diagram that I found online from this website. It's not the clearest picture, but it actually has some really important things. So I want to use that to demonstrate to you what the internet backbone is. So as some of you know, the way we connect in our homes, at a coffee shop, or at work is we usually have Wi-Fi, or maybe sometimes we still have people that are using Ethernet cables and connecting through those. But for now, let's just focus on the fact that we have a home and we have Wi-Fi, and this Wi-Fi essentially gives us internet from the router. You can see this little person over here working hard with a router next to him. And this router is connected all the way to something called a modem. And this is something that if you ever signed up for internet or changed providers, you most likely had somebody come to your house and install something. And that's this box over here that essentially allows the ISP, the internet service provider, this big building over here, we remember that, to connect to it. So this modem has these signal towers that transmit signals of, google.com, and it receives these messages. And then this is why I picked this image, just because I think it's incredible. You see this wire that is connected all the way to the ISP, and then the internet service provider, the ISP, is connected to this magical blue cable that is the internet backbone. And something that's really important in this image is the fact that there's Wi-Fi, which is over the air, but at the end of the day, everything is kind of connected through cables. So some of you, or many of you, or all of you might be wondering, what the hell is this internet backbone thing? Sounds cool, but this kind of vague. So I found a really, really cool thing that we can do together. I'll post this website in the notes after this lesson, but if you go over here, you actually see the internet backbone. So let's say we're in Brazil and we wanted to search google.com. Well, from Brazil, from our home, through Wi-Fi, it connects to our router, to our modem, and then all the way to our internet service provider. Let's say it's internet service providers over here. And then through cables, it connects all the way to, let's say, this point over here. And let's say for now that the Google servers are located somewhere in Portugal over here. Well, that signal of me looking for that IP address of Google and looking for those Google files is going to go through this submarine cable. Yeah, you heard that right. It's a physical cable that goes at the bottom of the seafloor from Brazil all the way to Portugal, where the Google servers are. And then the Google server says, yep, I got those files. Here they are. And sends it all the way back through the ISP, all the way back to our house. Like, isn't that cool that there's physical cables that are connecting and creating this internet? So, there are times where somebody destroys or something happens where these cable connections are cut off and you sometimes lose internet connection that way. But yeah, the internet backbone is literally just this network all over the world of connected cables so that we can transfer these files all over the world. And just to show you how insane this is, somebody from the Opti project over here, I got this off of Wikipedia, mapped out in, I believe this was in 2015, just 30% of the network. And you can see over here that each one of these dots is an IP address. So a computer that is connected to another computer, that is connected to another computer. And that's the internet. The internet is just all these connected computers that are just transferring files between each other. And as web developers, and this is the coolest thing, and that's why I just think everybody should be a web developer, because it's so cool. You're allowing this to happen. You're allowing this transferring of files from one computer to another, transferring knowledge from Brazil to Portugal and all over the world, and you get to be part of it. You get to be part of this network and you get to evolve. When this picture of the internet came to me, I knew that this was the career for me. So hopefully that gets you excited. In the next section, I'm going to show you something really cool, traceroute, before we finish up the lesson and we get into the next sections. So hope that was cool. See you in the next one. Bye-bye. Hello, welcome back. We mentioned in the last lesson that we're going to be talking about traceroute. What is that? Well, I just wanted to finally get the entire picture of the internet across, and I think this is the best way to do it. Now, if you're on a Mac, you're going to press Command Space and look for a program that comes with your Mac called Terminal, and you're going to press Enter and you're going to get this. So it's an application that all Macs have. If you're on a Windows machine, it's called Command Prompt, and in the exercise right after this lesson, I will show you instructions on how to access that as well. We're going to talk about traceroute. And if you remember, we spoke about this image of all these connected things happening and going to the internet backbone, and then google.com finally sends us the files back to our house, and you can actually monitor how that's going to work using traceroute. So if we type in traceroute, and on Windows machine it's actually traceRT, but for now we'll just go traceroute, and you can request for whatever website you want. So let's go with google.com. I press enter, and yep, look at that. It gave me a whole bunch of hops that it did. So you can see 1 through 9 here. So it did 9 hops. So that means 9 stops to this address at 172.168.1.14. So again, that looks like the IP address. So again, let's always test our experiments here. If I put that in and press enter, we should get google.com. Let's see. Look at that, google.com. So that's a fun little way of you to see where your requests go, and you can monitor, you can see all these IP addresses are different computers that are trying to locate the Google service. So go ahead in the next section, there's a little exercise. You can play around with this and just see where all your requests go all over the world. I think it's very, very cool. We're going to finish up in the next section with some fundamentals and what we can do with this knowledge that we have to actually become really good web developers. So see you in the next section. Bye-bye. And welcome back. In the last section, we talked about the World Wide Web and the internet and what the differences were. And then I promised you that we'll finally talk about some HTML, CSS, and JavaScript. So I've been vaguely referencing these files and just told you that they're simple text files for now, but what are they specifically? Well, initially, if you remember, we had Tim Berners-Lee who created the very first website. And this website uses HTML. And HTML, that's the first file over here, is a way for us to just write text on website. And these texts on websites can also have these things called hyperlinks that can link to other parts of the website. So that's what happened in 1991. 1991, we had a way for us to share documents. And this can link to another website, another file, another research paper. But as you can see, it wasn't the prettiest. So in 1995, 1996, two technologies came into being. One was CSS and one is JavaScript. Now, what did they allow you to do? Well, CSS solved the problem of, well, this is nice and all, but it wouldn't be nice if we had some visual aspects. We can toy around with this website and make it look pretty. And then JavaScript said, well, ideally we'll be able to have something like this website where, I can click over here, I can shop now, I can put in my credit card and get these fancy slippers, and I can do all this interactive things with my website. So let's play around with this and try and incorporate from this basic HTML file to add some CSS and JavaScript to this page. The way we're going to do that is we're going to go into View, Developer, and Developer Tools. So you might remember this from our previous lessons. So once you click on that, you'll get this pop up at the bottom of the screen. For some of you, it might be on the right side, but it doesn't matter. You'll get both things. And we've seen this before. And if you look at the top over here, it says HTML. And that's it. HTML is this. It's this file that has this weird syntax that describes how this web page should look in text. So you can see over here, it says the World Wide Web. These are just text. On the right side over here, you'll see something called styles. So styles will actually let you add styles to the website, as the name suggests. And that's what CSS is. If we click on HTML here, and actually let's click on body. Without knowing any CSS or anything, if we define something like color, semicolon, and then let's go blue, it changes the text color to blue. Chrome lets you play around with websites and actually inject some CSS into this HTML. Without knowing any CSS, we can kind of play around, type in a letter, and it will have a drop down. So let's see over here if we can do background color. Let's make it, I'm going to press tab, I'm going to do red. Make the website really, really, well, frankly, pretty ugly. But that's CSS right here. We've just added some CSS to this basic website. Let's turn this red color off because it is not pretty. Okay, so HTML, text and links, CSS, pretty colors. Now, how can we add some JavaScript? So remember, we have 3 files over here. JavaScript came along and said, these are great. We have these beautiful text websites that link to other pages, and we have CSS that can make websites really, really pretty. But would it be nice to have some interactivity, to have drop-down menus to make websites like they are now, interactive? We can actually do this, again, with the developer tools. If you click on console over here, without knowing any bit of JavaScript, for now we're just going to show you a simple JavaScript line. And we're going to type in alert and let's say, hi there, exclamation marks. And I press enter. And look at that. We just made the very first website ever made interactive with JavaScript. Now, obviously, this doesn't do anything, but hopefully this shows you where we were before in 1991 to where we are now. Websites that are interactive, full of JavaScript, CSS, and of course, HTML. See you in the next one. Bye-bye. Hello, and welcome back to a very exciting section. Why is it exciting? Well, we finally get to code, and we're going to start off by learning HTML and then finally building our very first website. In order for us to get started, we need to set up our environment, and we do that by, let's open up Google Chrome, and we're going to search for Sublime Text. This is a text editor that a lot of developers use. I myself have used it for years, absolutely love it. In your day-to-day job, you'll use something like this. I highly recommend Sublime Text. If you have a Mac, the version over here. If you have a PC running Windows, you'll have the download link for Windows. So for me, I'm going to download for the Mac. And you can see here it's downloaded, and I can drag it to my applications folder if I want. And we can double click. And if this is your first time downloading Sublime Text, you'll get something like this to give it permission to load. And there you go. We have Sublime Text. Now, what is a text editor? A text editor is a program that allows us to write code. You can see over here on the right-hand side of Sublime Text that it just says plain text. So I can type anything that I want, and there's nothing much different than if you wrote this in Word or a text file. But the power with a text editor, especially with something like Sublime that's geared towards coding, if you click on plain text here, you'll have a whole bunch of options of what type of code you're writing. So in our case, we're doing HTML. So if I click on HTML, nothing changes except for the bottom part over here. But now, if I type something, well, everything looks the same. But if I start typing HTML, it'll actually recognize it and help with syntax. So here, now, if I write HTML, look at that. We get a nice little color completion. So for us, for now, we're going to be writing HTML. You can see over here that there's different options. There's, where is it? There's CSS, JavaScript, which we'll learn later. So we're going to be using Sublime Text for this. For now, click on HTML, and let's write our very first web page. In order for us to have a web page, we write HTML, which stands for Hypertext Markup Language. So bear with me here. This is going to be new, but keep in mind that this is exactly what every single HTML page has. These are the set of rules that all HTML files must follow. And it goes like this. We define a doc type, and don't worry, I'll get into what that means in the next video. Then we have HTML, and we close these tags, HTML. The second part, we have a head and a closing head. You can see over here some patterns forming. Don't worry, I'll get back to these tags and explaining what they do in a bit. And then we also have body and then closing tags. And finally, here in the head, we have something called a title tag. Okay, so this over here is the rule that every single HTML file must follow. Just looking at this right now without knowing any HTML, you can get an idea of what everything means. So HTML, we're defining that this is an HTML. We're saying that this is the head of the HTML with the title. And we're saying that this is the body of the HTML. So let's try something here. Let's save this file. And we're going to save it. Let's do desktop. and we're going to call it index.html. You can see that it's already completed the HTML syntax for us. Save, and we have an index.html file here. Let's drag this all the way down to our Google Chrome and open it up, and well, nothing happens. But let's add a bit of text to it. So in the title, I'm going to say my first website, exclamation mark. And then in the body, I'm just going to put hello there. Okay, so if I save this, and just to show you from now on, I'm going to be doing Command S to save, just because it'll be faster. And now, if I refresh this page, I have hello there. And you can see the power over here of what we just did. We have hello there as the text, which is in the body. And then we also have my first website as the title. And you can see over here in the file that we're referencing index.html on my desktop. So we can see here that we have HTML, we have the head, which we haven't really talked about yet, but we see that the title is in the head, kind of like a header. And then we have the body, which by looking at this, we can assume that it's whatever shows up onto the web page. Before we expand on this and make it a little bit, well, prettier, because now it's just simple text, I want to reiterate the fact that what we've just done is very similar to what a server does. If we go back to our mockups here, you remember that when we enter google.com, the servers send us an HTML file back. When we move the index.html file all the way down to Google Chrome, that's what we just did. We mimicked a server and we gave it to the browser to load up the HTML file. And because browsers are built to know what HTML files are, it can read the syntax and say, okay, yeah, this is an HTML. Okay, you want my title to be my first website, and you want my body to say hello there. That's perfect. These are the default HTML rules that you'll see all the time. It is a little bit confusing at first, but this is it. You just have to remember that there is a tag, so an HTML tag, a head tag, a title tag, a body tag, and these tags usually have an opening and a closing. There's some exception to this rule, and we'll get into that a little bit later on in the videos, but just remember this for now. So I want you to try creating your very first website and seeing how it works. And once you're done with that, I want to show you that Sublime Text actually has a nice shortcut, so you don't have to keep writing those tags over and over. So the way you do that is you type in HTML and then press the tab key, and it loads all this up for you. Okay, so now that we've done this, I want you to go off and create your very first website. I know it's very, very simple. You can put whatever you want in the title, and you can put whatever you want in the body. And in the next video, we're going to start expanding on our first website. I'll see you in the next one. Bye-bye. Welcome back. In this video, we're going to expand on our knowledge and introduce you to a few more HTML tags and make this website look a little bit prettier than just hello there. To get started, I'm just going to move the screens around so you can see better. All right, so we have the left and right. And again, just to make sure everything works, if I change anything here to boo, and then I click save, and then I refresh the page, I have everything updating. Perfect. Now, these aren't the only HTML tags that you'll encounter. There's actually a ton of them. And if you go back to the w3schools.com, you'll see over here all the HTML tags that exist. There's a lot of them. We're only going to be going through, I would say, maybe 10 or 15 or so, because those are the only ones that, well, technically that I've used in many years of development. There's a few things on here that I've never even heard of, I've never used. You can always look these up and learn them yourself, but I'll say that there's about 10 or 15 tags that are used 99% of the time, and those are the ones that you'll encounter. So we'll go through some of those most popular ones. And HTML doesn't really get any harder than this. This is the syntax. As long as you get used to these little signs and structure, you're pretty much a HTML developer. So the first tag that I want to introduce you to is the H1 tag. So the way that I have it here is actually not right. You want to make sure that everything is surrounded by a tag. So a web browser right now can see Boo and just print out Boo. But if you want to do it right, you'd want to put something like an H1. And an H1 tag, if I save this and I refresh, we get what we call a header. So that is a header and then 1. What does 1 mean? Well, it actually goes all the way up to 6. So if I change this to 2, and I'm not going to do every single one. Let's just do another one. H6, Boo, H6. And if I save this and refresh the page, you can see that there's different sizes in the text. So that's the header tag. And again, if I scroll through the W3 schools and I go to the H, you see over here that there's the header tags explained here. And this website is really, really cool because you can actually click on try it yourself and you can play around with different things. Click run and it changes it for you. So again, this is a really, really good website for you to get familiar with all the tags. But again, we're going to stick to our website for now. Another thing that I want to introduce you to is something called a p tag or a paragraph tag. A paragraph tag lets you have paragraphs. So now if I refresh, well, there's not much different from what we had before, which was no tags and just saving it. Refresh. But you can see the difference when I copy and paste this and have a few paragraphs versus this. Let's see what happens. So I save this. You'll see over here that with Sublime Text, after, I don't know, I want to say about maybe like 20 saves, it'll ask you to make a purchase because technically this is an unregistered one. You can ignore it for now, just click cancel. Again, it's just one annoying thing that will pop up every now and then. I actually have a registered Sublime Text. I just wanted to show you this error so you're not surprised when you see it. Use Sublime Text for as long as you need it for free. When you start getting into the developer role and working full-time with it, I do recommend that you make a purchase. It's a great program and you still get everything through the unregistered. You just have this pop-up that shows up after a few saves. But anyway, from now on, I'm going to be using a registered Sublime account. I just wanted to show you that error. If I refresh the page here, you'll see that I have the paragraphs show up nicely, but these unstructured pieces of text, well, everything's kind of in line and HTML doesn't really know what to do with it, so it puts everything on one line. I also want to show you one other quick trick in Sublime Text. So writing this gibberish is not very exciting and kind of takes a bit of time, and developers are lazy. We want to make sure that everything is done fast and efficient. So if you actually put lorem here and then press tab, you'll get lorem ipsum paragraphs. So let's do that. I'm going to delete that, lorem, tab, and then one more, lorem, tab. Perfect. Let's save that and refresh, and we have nice paragraphs. As you can see, we have some tags and what we call nested tags. So you can see that the body is the parent, and Sublime Text actually lets you close and open these. So you have the body tag, you have the header tags, which are children of the body tag, and then we have p tags. A lot of people get confused in the naming. I've mentioned these as tags, so essentially anything that has this syntax is a tag, but this is called an H1 element. So that's when it's an entire block of functionality with content inside it. So again, tags, and then this is an H1 element. Again, it's just naming, but you'll hear tags and elements kind of used interchangeably, but those are the specific differences. All right, let's get into some of the more exciting things. Let's say, for example, I really want to emphasize lorem ipsum here. Well, I can use another tag, b tag, and then we close it at lorem ipsum. And let's make the screen here a little bit bigger just so you can see. There you go. So we have the b tags over here, and if I click save, I refresh. Oops. No, we don't want to translate this page. We see that this is now bolded. Again, let's make it a little bit bigger. There you go. Now, this syntax is actually not used anymore, or it's not recommended. Obviously, it still works. But there was a problem that HTML was initially used for websites that ran on computers, on PCs, on Macs. And now we have things such as mobile phones and iPads. Although the bolded text, and we actually have another one, which was the italicized I. Although we had this, for most phones, some of them didn't have ability to bold the text and didn't have the ability to italicize. Or some screen readers, which people who are visually impaired use, didn't really understand the meaning behind italicize and bold. So now we use something called strong for bolded. And refresh. And then for italicized, we use EM for emphasis. And there you go. Now, the reason this change was made was a move towards something called semantic HTML, and we'll get into that into a later lesson. But just know that there's some tags that have evolved over the years, and it's part of why HTML5 exists. We'll get into that a little bit more, but just wanted to give you a quick note on that. All right, I think that's enough for now. We're going to get into more tags in the next video. For now, play around, and I'll see you in the next one. It's time to flaunt your inner designer because we're about to learn some CSS. To start off, I want to show you this website. If you look at it, well, it's quite pretty. Look at that. That's really nice. Now, hopefully, in the future, we can create something like this. But I want to show you what this website will look like without CSS. Here it is. Pretty impressive, right? With just CSS, you'll be able to create something like this. So let's get started, shall we? I've created here for us a simple website. Nothing that we haven't seen before. You can see that I have created semantic tags with header, nav, an unordered list that has some links, a P2 and a P tag that's wrapped in another semantic tag called section. Okay, so again, nothing crazy. If I go to the About page, it's the exact same thing except for the About LI doesn't have an anchor tag. And then same with login. Okay, so let's talk about CSS. The way that we would add CSS to something like this is, well, we create a CSS file. So let's do that. I'm going to create a new file that I'm going to save. Let's call it style.css. If I save that, you'll see at the bottom over here that Sublime Text now has CSS as the file type. The rules with CSS are very simple. We essentially have a selector, and then we have these squiggly brackets, and within it, we put our property, semicolon, and then value. And then we have this special character as well at the end. And that is pretty much CSS. You know this, you can write CSS. Just like HTML, just a couple of syntactic rules, and once you get used to it, it's very, very simple. But obviously, this doesn't really mean anything, so let's write actual code here. I'm going to comment that out by, again, doing command / in Sublime Text. You can see that the commenting is different than in HTML. And let's say that we want to make this home text red. The way we would do it is we want to select what's called the selector. So here we want to say that the H2, we want that to be red. So all I would say is H2, curly brackets, and then within here, I want to say the property. I want to change the color to the value that is red. So if I save that and refresh, well, nothing happens. And that's obvious, right? Because how does this file know that this file exists? We have to link it somehow. And we do that in the head. And we haven't talked too much about the head tag element in the HTML section. But by now, you can probably tell that head just contains information about what the page needs. Maybe not the stuff that we see on a web page other than the title, but meta tags and information that we need for the website. Okay, so in here, we can actually link to this style sheet that we call style.css with a link tag. And this link tag allows us to link this HTML file to something else. And again, Sublime Text has something very useful here. If I hit tab, look at that. It autofills it for me. These are the standard attributes that you'll see to link to CSS. So you just have to get used to it and eventually it'll become second nature. So we have REL here, which is the added attribute for relation. It just specifies what relationship this link will have. And we have the default style sheet. And then for the type, this is the media type. We want to say that it's a text CSS file. We're essentially telling HTML, hey, just a heads up, we're linking to a CSS file here. And in the href, this should be familiar. We're going to link to style.css. So if I type in style.css and save, let's refresh, turns red. And just to let you know that index.html is in the same folder as style.css. We can check it over here. If I click on exercise, you see that, yep, I have style.css with index.html. Perfect. Okay, now what if we also want to make the paragraph over here a separate color as well? Well, again, we would do the selector and then we'll do color and let's do pink. I save, refresh, and it's pink. Hopefully you can see that. You also see here that Sublime Text does some really nice coloring for us. So if I, for example, I put a property that doesn't exist, like a misspelled color, well, you see that it doesn't highlight it properly with the blue color, and you know that you've made a mistake. Again, another great feature of Sublime Text. So CSS, what does it actually stand for? Well, it stands for Cascading Style Sheets. And style sheets, that makes sense that, we're creating style sheets, but what does cascading mean? Cascading means that it always takes the selector that is at the end. And that's simplified terms, but I want to demonstrate for you what that means. So let's say at the bottom over here, I do this again. Paragraph, I want color to be green. Well, if I save this, what do you think will happen? Let's refresh and see. It turns green. And why is that? Well, because it's cascading. It's saying, okay, I'll set H2 to red. Okay, I'll set paragraph to pink. And then it says, okay, I'll set P to green. So you can see here as it trickles down and cascades, it takes the last input that it receives for a specific selector. We'll get more into the cascading effects of CSS in a later video, but I want you to understand the basic concept around it. Okay, I also wanted to show you something cool that you can do with Chrome. And we did this in the first couple of video series, but now you'll actually understand what it means. So again, View, Developer, Developer Tools. And from now on, I'll be using this shortcut to open it, and you'll be able to do it as well. And if you remember, we have our Style tab. And if we click on the Style tab, we have the HTML on the left, styles over here, and nothing for the styles. But if I now go into my home and I click on that, it'll show you color red. So Google Chrome allows us to see our CSS styles. So I can even add stuff here and I could say background color. And let's do black. Look at that. So this is a really good way to play with your website and add colors. You can check and uncheck here. And also, if you see something on a website that you really, really like, you can go to that element. Let's try it off here. Let's go to waitbutwhy.com. And let's say that we really, really want to know how this was made. We can right-click, do inspect. It'll take us exactly to that element, and then we can see here some of the properties, the CSS properties that they've used. And same here, you can see that the background color is this, and so on and so forth. Okay, let's close that for now. The last thing I want to leave you with is, let's close this. What if I also want the About page to have styles? And same with the login page. As you can see, there's no style for these ones, but we want the same thing for the About and login page. Well, as you can imagine, we copy the link tag and we go to About. We link it onto here, and then login. We can again link it here. I save both of these files, and now if I refresh and go to About, look at that. We have our styles. And you may be wondering, well, what if I want different styles for maybe for the login? I want this to be blue instead. Well, we can actually create multiple style sheets. So I can say, for example, let's create a new file and we'll call it style2.css. I save that. And this time I'm going to say that I want my h2 to have color blue. I save that. I go into my login HTML, and now I'll make login reference the second style sheet instead of the first one. So now if I refresh, login is referencing our style2 CSS, but all the other ones are still referencing the old one. Okay, I lied. There is one last thing that I want to add, and that is that this is the common way of adding styles. But there's actually two other ways that you won't see as often, especially when you're starting off, but I wanted to show it to you so that you're not surprised. The first way of doing it is something called inline styles. And this was the original way that we incorporated styles into our HTML. And that is by specifying within the element, let's go with header over here. We want to say style, so it has a style attribute. And then within here, we can do background color. Let's do green. And refresh, and we're at the About page right now. We changed that for index.html, so let's go over here. And look at that. We have the green background. And if you want to add more, again, we do color red. Let's save and refresh. And look at that. The header has the color red. And you'll see here that these ones are still purple, well, because they are link tags and they have the default linking. Okay, so that's one way. And third and last way is in the head, you can actually create style tags. And then within these style tags, you can enter CSS. So if you just refresh here, so we have a fresh, clean slate, I can now say, let's do li this time. So all the lists, I want the lists to have background color of purple. So if I now save this and refresh, everything is purple, and that looks pretty yucky. We can keep adding stuff on here, and I can say color white, save, refresh, and it changed the color to white. Now you may be wondering, why don't we just do it like this? This seems a lot simpler than linking to another CSS file. Well, the reason is that for this website, everything is fairly small. It's just a couple lines of CSS, but you can imagine with websites, as they get bigger and bigger, you'll have hundreds and hundreds of lines of CSS, and having one massive file will be very, very challenging to maintain. You can also think of it as if you were working on an HTML and you also had a team of designers that were working on a CSS file, you want to have a separation where you have some team members working on the CSS and then some team members working on the HTML. And that is a concept called separation of concerns. And it's a fancy way of saying that everybody just worry about what they're good at. So HTML, just worry about text, and CSS, just worry about styles. This phrase, separation of concerns, is something that we'll encounter throughout later videos when we get into JavaScript and React. And it's a very, very important concept in web development and computer science in general. So we will get back to that. It'll be a phrase that will keep coming up. So for now, let's delete this. Let's keep things the way that we have it. Let's refresh. And in the next video, I'm going to show you a couple of CSS properties that are more exciting than just color and background. I'll see you in that one. Bye-bye. Welcome back. JavaScript was created in 1995 by the Netscape web browser, right over here. It was a way for them to be able to add actions to websites. Think of JavaScript as the verb in anything you do on a website. You tweet, you play a YouTube video, you sign up for a username. These are all actions we take on websites, made possible through JavaScript. In 1995, it was a way for this browser, Netscape, to beat the competition, which were other browsers at the time. Because at the time Netscape was the most popular, other browsers started adopting their own version of JavaScript so that websites will work on their browsers as well, and thus let people switch over to their browsers. Can you guess what happened next? Well, every browser had their own idea of what JavaScript was. So there was no standard. Eventually, a standard had to be created to make sure that everyone had the same idea what JavaScript was. So that web developers can build one website and have it work on all browsers. This standard was called ECMAScript. So yes, JavaScript and ECMAScript can be used interchangeably, and you will hear both of these a lot. But it's the same language. Now, this browser compatibility issue. Browsers having their own teams, their own schedule, and their own code. Sound familiar? Yep. If you remember, it's the same thing that happened with HTML and CSS. It's the same issue that we keep having over and over. We covered this topic in Web Developer Fundamental Part 2. You see, it's always a big problem. Make sure that all browsers have the same understanding of what a real HTML, CSS, and JavaScript should be. So that when we send each one of those files, we don't have to write one specific for each browser. And just like HTML and CSS, JavaScript is evolving. So there are new things that we can do now that you weren't able to do in 1995 with JavaScript. In the ES6 video section, later on in the course, we will talk about these new features, so don't worry. Now, let's take a look at what JavaScript does. We can open up the browser, and I have Udemy over here. Well, Udemy uses a lot of JavaScript. I mean, clicking on a course, adding it to cart, liking a post. All these things, well, they're all JavaScript. Even if you open categories over here, you see this drop down and I can select things and there's actions constantly happening throughout the website. That's all JavaScript. But it's not just the web that you can use JavaScript on. Instagram? Well, Instagram uses JavaScript. What about something else? Maybe virtual reality? Yeah, you can do that too. You can do VR games, VR apps with JavaScript. Okay, that's pretty cool. What else can JavaScript do? Well, you can actually program drones with JavaScript and control them from your Wii remote if you wanted to. What about robotics? Yeah, this guy built a robot that he can control from his web browser. How cool is that? Now, remember Node.js? We talked about this slide at the beginning of the course and how we're going to learn these topics. Well, some of this is able to be done because of it. But Node.js is pretty much JavaScript. It is JavaScript. So you learn JavaScript, you can pick up backend stuff very easily, and the Node.js section of this course will be a breeze. It's not a new language that you'll learn. So is Express, so is React. So this is why JavaScript is so important. What we will learn here will take you very far in the rest of your career. This is one skill that really opens up a lot of possibilities. Here's the beauty of JavaScript though, and any other programming languages. Because what is JavaScript really? It's a file. A file that you can write instructions to a computer. In the example of a robot arm, all you had to do is write, if I press this button, move arm to the right. If I press this button, move arm to the left. It all looks extremely complicated, but as you will see, no matter how complex a program, let's say an online game like World of Warcraft, well, everything is built one block at a time, one simple logic at a time. In the next section, we're going to start writing our first JavaScript and our first simple pieces of logic. Don't let it fool you though. Although it may look simple, these are the building blocks that allow you to build big web apps like Facebook or Google. Exciting things are going to happen with your newfound power. So, I'll see you in the next one. Bye-bye. Hello! Let's learn some JavaScript. We're going to open up Google Chrome here, and we're going to go to View, Developer, and this time, JavaScript Console. So you can do Command Option J as well. And it opens up this console, which is, if you remember Elements, you've seen it before. That's your HTML. Console is where we can write JavaScript. On the right, you'll see the outline of what we'll talk about in this JavaScript segment. We'll go one by one, and some of them we'll come back to. But don't worry, by the end, you'll know everything in here. So let's talk JavaScript. JavaScript has 7 types. You can think of types as values that JavaScript can have. Let's start with the first one, and that is number. So the number type. Well, in JavaScript, you can do something like this. Look at that. The console allows us to write JavaScript as much as we want. So by writing this and the console giving us an answer, it means that, yep, this is valid JavaScript. Okay, what else can we do? Well, we can do 3 times 5, 15, 12 divided by 4, 3. That's awesome. What else can we do? 12 minus 4, 8. Can we do this? Can we do 3 plus 4, close the bracket, times 2? So that's 7 times 2, 14. Yeah, it works. And we can even do this. And this is a special character that you might have not seen before. It's called modulo. And let's see what happens. It gives me 0. What if I do 12 modulo 5? It gives me 2. What this symbol does, and let's make this bigger so you can see clearly. And I'm going to clear this just so you can see it better. And I can do clear here with these brackets and it'll clean up everything for me. So one more time, what I did was 12 modulo 5, and that gives me 2. And what modulo does is it gives me their remainder. So 12 divided by 5 is, well, it gives me a remainder of 2 because 5 can only go to 10 and then you have 2 remainder. So if I do, let's say, 12 modulo 5, or let's do 9, I get a remainder of 3. And you're thinking, oh God, you're just teaching me math. But don't worry, this is only a small part of it. I just want to show you that the first JavaScript type is a number, and we can do operations on them, just like a calculator can. The second type in JavaScript is a string. So a string is just text. And all you need to do to let JavaScript know that you're writing a piece of text is double quotes. So I can just say Bob, I can say my name, and you can also use single quotes. And that is a string. But what else can we do with the string? Let me clear this. Well, you can also do this. You can say hello plus there. What do you think will happen here? Let's see. Hello there. But it is one word. We need a space. So we would have to do hello space plus there. And there we have the space. Okay, so we can add things. So add two sentences together. What if we do something like this? This isn't very nice. I hit enter and okay, that works. That's good. But what if I use single quotes here? What if I go like this? And remember I said that I can use single quotes in JavaScript. Well, you see the syntax changes and I get a little error. Well, because I'm using a single quote and then inside the string, I'm trying to use a single quote. And that would happen as well if I use double quotes. So if we go back to the example before and I add another quote in here, well, again, I get an error. So let me clear that. How can we avoid this problem? Well, with the string in JavaScript, you can do something like this. Let's use single quotes. This isn't, and watch this. This isn't very nice. And this backslash has a special meaning. The backslash says, hey, whatever comes after this, it's a special meaning. It means just ignore it. Don't say that this is a piece of string. I just want the backtick. So if I run like this, oh, oops, I made the syntax over here wrong. Obviously the quotes need to match. So let's try that again. There you go. This isn't very nice. Okay, I have another question. What happens here? 10 plus string of 34. So that's number 10 plus string of 34. Let's see what happens. Weird. So JavaScript automatically looked at this and said, he's adding a number and a string. He's probably trying to add strings together. So JavaScript converts the number 10 into a string 10 and does 1034. That's kind of weird, right? It's one of the quirks of JavaScript. There's a few of them. You just have to get used to it. Let's try something else. What about if I do 10 minus 3? Press enter. I get 7. What is going on here? And because with the string, you can't really subtract the string. I mean, let's see if I go hello minus by. I get this weird symbol, which we'll get back to, but that doesn't work. So now JavaScript says, I'm going to, because he's subtracting, I'm just going to assume that he means the number 3. So he's trying to help you out. But sometimes it can have unexpected behavior. So ideally, you never do things like this. Ideally, you keep numbers with numbers and strings with strings, and you keep the actions between the like types. So let's go back to this. What just happened when I say hello minus by? Well, NaN stands for not a number, and it's technically in JavaScript, you can see the blue highlighting here, it's part of the number type. So numbers can range from 1 to 10 to 567, but there's also the NaN when it's saying, hey, whatever you just wrote is not a number. So that's the case as well. I know it's really, really confusing, but don't worry, it's just the quirks of the language that we're learning. Okay, I'm going to show you one other JavaScript type before we get to some fun things in the next video. So the next one is Boolean. And the Boolean type is very simple. Boolean just means true or false. That's it. And sometimes that could be represented as ones and zeros. And for those that know a lot about computers, you might know that computers pretty much runs on ones and zeros. And that's where it comes from. But Booleans are very, very useful because now we can do something like 3 is greater than 2. And I'll say true. 3 is greater than 2. If I do 5 is greater than 10, we'll say false. 5 is not greater than 10. We can also do 5 is greater than or equal to 5. So we'll say true because I can do greater than and equal to. And I can also do 5 is smaller than or equal to 5. Now, what if I want to say, does 3 equal 3? I get an error. Why is that? Well, because in JavaScript, if you want to say something is equal to something, you have to say 3 equals sign 3. And I get true. And in the next video, I'll tell you why that's the case. It's very, very interesting. But for now, just remember that's always a tricky point that a lot of beginners get confused about. Just remember, if you're comparing two things, 3 equal signs. The last one I wanted to show you is this. 3 doesn't equal 3. Isn't that confusing? So this is saying, does 3 not equal 3? False, because 3 equals 3. I know it can get really, really confusing, but think of this as the opposite of the equal sign. So for example, if I do 4 doesn't equal 5, I'll get true because you're right, 4 doesn't equal 5. So what we just learned are JavaScript comparisons. And they're the things right over here. That's it. You just have to remember these. Whew. Well, that was fun, right? But we're just getting started. After this video, I have left an exercise sheet for you. Try to find the answers to the problems and then copy and paste them, each of the questions, each of the line, into the JavaScript console. So for example, if I said, evaluate 3 plus 5, you'll copy this, put it in the console, and just press enter. And I want you to get comfortable working with the console and playing around with it, experimenting around. And like I said, really try and work on the next problem sets. I haven't given you a lot because I don't want you to get overwhelmed. There's a lot more interesting things happening in JavaScript than this, and you can pick this up fairly easily. But I do encourage you to make sure you do the exercises. Now, can you get all of them? Good luck. I'll see you in the next video. Bye-bye. And welcome back. We're going to take a quick break from learning JavaScript syntax to show you how JavaScript gets implemented in the browser. We're going to go back to this image that we've seen many times before in this course. And we have a pretty good idea of what HTML and CSS does. If you remember, HTML gets sent to the browser, then it sees the link tag, and the CSS gets sent to the browser. But what about our new friend JavaScript over here? What happens with him? Well, in this video, we're going to learn exactly that. So I have over here an index.html file. I'm going to open it with Google Chrome. It's completely empty now. And I'm also going to drag it to my Sublime Text so that we can add something to it. So I have Sublime Text in the browser, and we're going to use our little short command to create a quick HTML file, JavaScript, and let's just have a simple header that says JavaScript in HTML. Save and refresh. Perfect. We're masters at this already. We all know what's going on. So how do we add JavaScript to this? I mean, with CSS, we had the link tag, right? And we had this href where we tell it where it is. Well, if you remember, JavaScript, again, just like HTML and CSS, is just a file. So let's create one first. In Sublime Text, I'm going to create a new file. I'm going to save it, and I'm going to say script.js. See the .js at the end? That means JavaScript. Notice what happens when I click save. At the bottom, Sublime Text now converted the syntax to JavaScript. So now I can write something like 4 plus 3, and I get the cool JavaScript colors. I can write if 4 plus 3 equals 7. I can alert you're smart. So you can see that it does the syntax for me. Okay, perfect. I'm going to just save that. Let's see if we can add this to, I forgot the semicolon here. I always forget it too. Let's add this to our HTML. If it works, we'll get an alert saying you're smart. So how can we do this? Well, there's an HTML tag called script tag. So link tag for style sheet, script tag for JavaScript. And all we do is this. We have the type text JavaScript. You see over here how with CSS we have text CSS. Well, we're telling it that this is JavaScript. And in here, JavaScript can be written right over here. If I go alert hello, and you might remember this because it's kind of like the style tag for CSS. Let's see what happens. I'm going to refresh, and I get hello. Look at that. We just added JavaScript to our HTML. But I really want to use this file. As we know with CSS, we don't necessarily want our JavaScript to live on HTML. We want separation of concerns. We want the JavaScript in the JavaScript file. Well, the way we do that is through a source file. So all we do is source. You might remember this from images. So instead of href and link, we have source and we say script.js. I save and I refresh and I get you're smart. Now, again, we can say script.js because, well, it's in the same folder. It's in the desktop folder. If it wasn't, then let's say this HTML wasn't in the desktop folder, we'd have to do something like desktop. Okay. So that's very interesting. What if I have multiple JavaScript files? We might have seen that in, remember Bootstrap? In Bootstrap, we had like 3 script tags. Well, yeah, you can just like you can with link, you can have multiple script tags. And you can just say script 2, script 3. And again, each one gets executed one at a time. Okay. Now, one question you might have is, why did I just put the script tag at the bottom here, at the bottom of the body? Why didn't we, and let me just remove this for now, why didn't we just put it at the top like we do with the CSS file? Well, let me show you something. Let's put it up here. Let's see what happens. I'm going to refresh. Okay, I get you're smart. I don't know if you saw that. Did you see the JavaScript go? Let's change this quickly. Let's say our website is now fresh and new, and I'm going to say waiting for JavaScript. I'm going to save. Notice what happens to the header. I refresh. It hasn't changed yet. I have to click you're smart. You see it? It's completely gone. Click OK. And only then it shows up. Because the browser reads the file, goes and gets the CSS file and then sees a script tag and says, "Ooh, I'm going to go read what's over here. And here is an alert." And what an alert does, it waits for us to click OK. So the browser can't display waiting for JavaScript. So you will see in older websites people that put the script tags in here, but that actually delays what gets seen by the user. Instead, if we put it down here and change the text again to not waiting, I'm going to save. Let's see what happens. Not waiting for JavaScript. That got changed. So we ideally want to put our script tags at the bottom of the body. What that means is that the website gets displayed, gets rendered, and then we have to still wait for the JavaScript to load. Let's say we had a cool animation. It will have to wait until that loads, but to a user, it appears like the website loads a lot faster because they might not click on a drop-down menu or see the animation right away and notice that there's a lag, but they will see a delay if they don't see anything on the page. So script tags at the bottom. One last thing. How do we get that console to print stuff out? It would be nice if instead of alert all the time, I can get something in the console. Well, in JavaScript, you can do something called console.log. And here I can say, hello. So this syntax is a little bit weird. I'll explain later on what is going on here, but console.log is a special little syntax that we can use. And now if I refresh the page, I get logging over here. So I can write as much as I want here, kind of like alert, but without getting that annoying pop-up over and over. And refresh, and I get hello. And we'll be using console log a lot in the next couple of videos. You can see here that it's a nice way for us to print something to the console before we learn how to change our HTML. So I'll see you in the next one. Bye-bye. In 1989, Tim Berners-Lee invented the HTML that changed the world. But HTML wouldn't really do much if we couldn't fetch documents from around the world and different computers. For that to happen, Tim built the Hypertext Transfer Protocol, or HTTP for short. Now, remember these arrows from the diagrams that we've had? We told you that these arrows were simply the connected wires and cables that connected the World Wide Web. This, right? You remember the diagram. But you see, these are just wires. There are no instructions on how to do things. For that, you need something called a protocol. Think of it as a standard that everyone follows. If everyone agrees, then the protocol works and can be used by everyone. HTTP that I have here is a protocol which allows the fetching of resources such as HTML documents. I mean, it's in the name, right? Hypertext Transfer Protocol. Now, with the use of HTML and HTTP, we now have the World Wide Web. We can grab HTML files and receive them. If we go to google.com/about, we go to the About HTML page, we grab it and receive it. So HTTP is the protocol or the rules that we use over the wires. It is the foundation of any data exchange on the web. And it paved the way for something called a client-server protocol, which means requests are initiated by the recipient, which in our case is the web browser. So they send out a request using HTTP. The server now understands what the web browser is saying because it's speaking in HTTP. And the server can now respond with HTML, and the browser understands it because it's speaking through HTTP once again. So you should think of HTTP as a common language that a client and a server can use to communicate. They're simply saying, hey, can you give me this document? And the server can say, yep, no problem, here it is. And up until this point, we haven't really spoken to a server in our app, have we? We built the front-end applications or the client-facing applications using HTML, CSS, JavaScript, and React. But we lived in our own world. No communications with another computer. HTTP allows us now to communicate with servers, with the outside world. So let's go over the terminology one more time. Clients and servers can communicate by exchanging individual messages. The messages sent by the client, usually a web browser, are called requests, and the messages sent by the server are usually called responses. So if HTTP is the language that allows us to communicate between these two, teach me some of the words, right? I mean, that's a good question. And lucky for you, HTTP is quite easy to learn because you only have a few words. And I'm going to show you what they are right now. You have get, you have post, you have put, and finally you have delete. And now you're thinking, that's it? And yeah, HTTP is beautiful because it's just simple. You don't need to overcomplicate things. You learn these 4 words and these languages, and you can build the app of your dreams. So let's go through it one by one. Get means, well, I want to get an HTML file. So you ask to get something, and the server responds with that request. A post says, I want to post something. So that is, I'm going to send over some data to Google servers, and I want you to post. I want you to add it to your servers or your database. Put is, I'm going to send you some data, and I want you to update some data that already exists in Google servers and just update it with this new information. And then delete means, well, delete a piece of data on the backend, on the servers or on the database. So if we use Twitter as an example, get will be to receive the Twitter feed with all the tweets from today. Post would be if you created a new user and you want to add that user to the Twitter servers. Put would be if you made a tweet but you want to make a change or an edit, so you edit that tweet. And delete will mean, well, you either delete your user account or delete a tweet. And don't worry, we're going to use these when we get to the backend section and we build our final project. Now, over the years, HTTP was extended to not only worry about text, not only fetch hypertext documents like HTML, but also images and videos and post content to servers like with HTML form results. And HTTP can also be used to fetch part of documents to update web pages on demand, which is called AJAX. And we have a video coming up talking about this. But the main idea still stands. Using these 4 verbs we just learned, we can now communicate with servers. All right, so we know that this arrow over here at the top uses HTTP to make requests using one of these 4 verbs. Okay, so I think you get the request part. Now, what does the server respond with? What about response here? The server sends you 2 main things. One is an HTTP message that is something that you've definitely seen before. And I'll link to this W3 Schools resources. A 200 message means successful. You probably have seen 200 OK before. You might have seen 404 messages, which means not found. If you enter a URL that doesn't exist, you'll get a 404. And maybe sometimes you'll get a 500 error message that is, well, there's something wrong with the server. So this is just a number code that comes with every response that tells you the response of the server. So that's the first one. The second one is usually some sort of data, like HTML. And so far, that's what we've been doing, HTML. But in the next videos, I'll show you that it can send other things other than just simple HTML. So let's add to this diagram now. We want to say that this also has a status code, and we'll say 200 for now, that everything was fine. And in the response, we give the status code plus the new HTML file. All right, let's actually demonstrate this online and see how you can watch this action take place. I have over here a great website called example.com, and it's a simple website. You can go visit it right now. But the cool part about it is if you open up your developer console, up to this point, we've looked at the Elements tab and then the Console tab. I want to show you the Network tab that we have here. Now, the Network tab, you might have to click on some of these icons, and you'll see that different things will pop up. Make sure that the filter is gone. Everything is unclicked. And now at example.com, while this is open, just simply refresh. And look at that. I'm going to click on this icon, which makes it a little bit bigger. This is a plugin, so don't worry about this JavaScript. But the top thing, it says example.com, status 200 OK, and type document. And it even tells me the size, the time that it took to get this, which is 53 milliseconds. That's pretty fast. So that means the server responded with 200. If I click on this, I get a whole bunch of things that we don't really need to worry about, but a few things. Request URL, this is what we requested. We get a status code of 200 from the server. And if we click on the response, there's the response message. We received the HTML document from the server. If we go back to headers, we also see that our request method was a get. We did a get request. Let's close this and refresh again. I now get a 304 status. A 304, if we look over here, means not modified. Indicates the request page has not been modified since the last requested. Because I've already requested this now, Google is smart enough to say, oh, I'm not going to worry about the server and requesting the same thing over and over. I already have it memorized, so here it is. Very cool. So Network tab is really, really useful for that. All right, so you can go ahead and play with example.com and see for yourself how HTTP works. And by the way, yes, this HTTP that you see here, that's what it means. When you do an HTTP request, it says, hey, do HTTP. We're using the World Wide Web and go request this from the server. Very cool. And if you're wondering about the S, don't worry. I'll let you know at the end of this video what that means as well. All right. Now, what if I want to send data? If we go back to our diagram, I'm just doing a GET request. But what if I want to actually send some information to the server other than some URL saying I want this information? Well, there's two ways that you can do it. One is something called query string. And then the second one is through the body of the request. So I'm going to show you how both of those work. I have over here the form that we created in our first advanced HTML section when we only knew HTML. Let's open this file up. I have it over here. If I double click, you remember this, don't you? We've come a long, long way. In this form, if you remember, we had a form method get. And now you might understand what this get means. It's saying, with this form, I want you to do a get request. Let's see what happens when I click register while opening the Network tab. I'm going to click register. All right, so we have this request. We see that we have made a request and it has created these things called query strings, the first way of sending data to the server. With a GET request, if you want to send information through a form, it adds it to the URL. using this question mark, which says, hey, I'm about to send you some query strings, and it's going to have a key and a value. In this case, first name, last name, everything's empty, so there's no information, but otherwise it'll say first name equals Andre. If I click on this, we see that there's query string parameters that we've sent. We have first name, last name, email, password, and birthday, which is blank. But if we scroll down, in cars, default is Volvo, so that we have cars Volvo. So this information now is sent to the server. That's query string parameters using get. And we did mention one thing though. We see that we have password in here. That's not very secure, is it? If I went back to the form and I type in secret and I click register again, well, now I have my password out in the open, sent over the wire, and I even have it up here, my URL bar. All right, we'll get back to that. So that is one way. The second way is through the body of the request. Let me show you how that works. The way we send information to the body is we use a post request. And this is something that you'll more often see than a GET request, is that we want to add some form data to the server. So we want to post something. If I change this over here, I'm going to save this. And let's open up a new tab with the new saved data. This one is a post form. If I open it up here and I type in password secret and I click on register, I get register.html, but no query strings. If I click on this, I see that now instead of query strings, it's form data. And it even says content type, application, XWW form URL encoded. And this is just an HTML way of saying that this is a form and this is the body, but not displaying here. So now the server can access it not from the query params, and don't worry, I'll show you how servers do that when we get to the backend section. Instead of accessing it through the query params, I can now access it through the form data. So let's go back to the diagram. We now understand that we can do HTTP requests using get, post, put, delete. I can use query strings, which are at the top of the URL, to send the data, or the body of the request. And then the server responds with a status code based on how my request was, and it returns that with a response. But the one issue we saw was that, well, the password was visible in both cases, wasn't it? And what if I have a scary looking person over here? There you go. What if we had a person who was watching our communication, our HTTP requests, and monitoring it? If I used query strings to put my password in there, well, he can just look over my shoulders and see, oh, Andre's password is secret. I can now log into his Google account. Or if I use the body way of sending data, well, he can find a way to get this request to come over to him first and just look at the form data and see that my password is secret. That's not very good, is it? Well, one solution to this was the idea of HTTPS. Now, HTTPS means Hypertext Transfer Protocol Secure. And you can see over here that W3C uses the secure version of HTTPS. The communication between the browser and the websites are now encrypted. And what does that mean? Encrypted just means that it's jumbled up, so only the client and the server know the secret pass or secret key to read the message. And this SBART, the secret, uses a technology called Transport Layer Security, or its predecessor, Secure Sockets Layer, or TLS and SSL for short. So now, even with HTTPS, if the attacker, or what we call a man in the middle, the person who's just monitoring our requests, even if they get our password, it's going to be just complete gibberish. It's going to have something similar to this, and well, that's not our password, so it's going to be meaningless. It avoids that attack. This is just a tip as a developer that you should tell all your friends. If you're ever sending sensitive information, maybe logging into a bank account, make sure that there's HTTPS out there. If there's no HTTPS when you're sending maybe your login with your password, well, that's not secure. All right, let's review. Your web browser is a HTTP client sending requests to the server machines. When the browser user enters file requests by either opening a file or typing a URL or clicking on a hypertext link, an anchor tag, the browser builds an HTTP request and sends it to communicate with the server. Now the server can get information back to us. The earliest version, we could use URL parameters such as google.com/about and just specifically get HTML. That was it. Then came the form. So we can now actually send more data other than just the URL saying we want to go to this HTML file. Now we can use get or post to send data, either through a body or a query string. And a server can take action based on that data and return a new page. And this is the foundation of the web and how the World Wide Web we have now was made possible through client-server communication. In the next few videos, we're going to learn even more to really understand this power. I'll see you in the next one. Bye-bye. All companies store data. From a simple record book of a small business, maybe even on a journal or a piece of paper, to massive companies like Amazon that need computers to store petabytes of data. Now, in order to store this information, pretty much every company, and sometimes individuals too, need something called a database. We saw in the last section how hard it was to have our server remember a new user. Every time the server crashed, the variable would get reset and then it would start all over. Or if we wanted to do a login or a sign-in check and iterate through the emails and passwords, doing a loop through JavaScript, that's inefficient. That's where database come to the rescue. So let's ask ourselves, what is a database? A database is a collection of data. And what we mean by data, there are many forms of them, right? There can be numbers, there can be dates, there could be password hashes, there could be user information. Databases allow us to organize this data in a way that is useful to us. And it makes data management easy. And something came out of that. And it's called Database Management System, or DBMS for short. It's a collection of programs which allows us to access databases and work with data. And it also allows control access to database users. So a DBMS is something in this box. Something that allows us a tool, a piece of software that allows us to communicate with the database, store information that's useful for us, and also allows us to update, insert, delete, look up whatever is in the database. And this idea of a DBMS really started to take shape in 1960s. And now it is at the forefront of many exciting things. There's an entire industry of engineers that just work with databases because it is so important. Now, there are two types of DBMS that are really popular right now and that we're going to talk about in this course. And these two types are represented really well by Postgres and MongoDB. Let's talk about the first one, which is relational database. And this is probably the most popular. As you can see on the right-hand side, you see that all of these are relational databases. Postgres, Oracle, SQL Server, you may have heard of MySQL, SQLite. These are all types of databases that have this relational database tag to them. And the beauty with them is that they're all pretty much similar. They all follow a same standard format. Relational databases consist of two or more tables with columns and rows. So in this case, users is a table, and full name, username, text created at are columns, and whatever values they have here are rows. Each row represents an entry, and each column sorts a very specific type of information, like name, address, or phone numbers. And then the relation between tables and fields is called a schema. In a relational database, the schema must be clearly defined before any information can be added. And if this is confusing right now, don't worry, we're actually going to create these databases so it makes sense to you. If we had Twitter, for example, you can see over here the types of tables that we would have and how we would organize it. We would have a users table, a tweets table, a following table, and we can connect all these information, for example, by connecting different pieces of the table. For example, the username will be the same in the users table as it is in the tweets table. That way, we can say that the username in the tweets table is the foreign key of the username in the users table. And then from user will be the foreign key of username in the following table. Now, things like full name or ID, something that identifies each row in a table, is called a primary key. And we'll go through that later on in this section. All right, so all these databases, we're going to learn about PostgreSQL, but they're all pretty much the same. So once you know one, it's fairly easy to pick up the other ones. How do they actually communicate with a server, with the backend? Well, all relational databases use something called SQL. And SQL allows us to communicate, just like HTTP did, between the front end and the back end. With SQL, we're able to communicate with the database and modify or get or update however we want. And we'll have a video on this topic as well. All right, so that's relational databases. What about the second type? The second type is called a non-relational database or a NoSQL database. And once again, there are many, many different types of databases with some cool names like CouchDB and Hypertable. Now, a MongoDB or a non-relational database lets you build an application without having to define the schema first, unlike a relational database. If we go back to relational database, this schema or these tables have to kind of be predefined, right? We need to know how our app is going to look, make these tables so that once the app is public, we can start entering user information and tweets and followers. With a NoSQL or non-relational database, we can just define it as we go. And they all have different ways of storing this information. So each one is very, very different. And this is another powerful reason to use a non-relational database is that if your data requirements aren't clear at the outset of your project, and maybe you have a massive amount of unstructured data, you may not have the luxury of developing a relational database with a clearly defined schema. They offer instead a greater flexibility in that a non-relational database are more like folders, just assembling related information of all types. Now, MongoDB is something called document-oriented. It stores information as documents. Let me illustrate this point to you. I have my desktop here with two folders. One is a relational database, and here I have users, tweets, profile, following. And you can think of relational databases with this type of storage, where this folder lives somewhere on a computer that stores this information. And anytime we need to ask a database for something, well, we grab the users. And if we also want to grab the tweets of the user, we find the user that we're interested in, then find the tweets of the user that we're also interested in with the foreign key that links to the users. And we can also find however many followers that user has. We grab that information and display it on our web app. MongoDB, on the other hand, will actually have each user as a document. So if I wanted to grab the first user, well, I just grab this document and it has all the followers, the tweets, the profile, everything is in this one document. And you might be thinking, MongoDB looks like a better choice than having this way of doing things, right? Well, it depends on your need, and that's why databases is such a complex topic. It really, really depends on your situation. You can see this MongoDB way being very useful if you had something like a profile, maybe a LinkedIn profile. But if you needed something where you're working with just following data or just tweets data, maybe with the tweets, you want to see what is the average tweet size. Well, it's really easy to just grab this file and calculate that versus this way where you might have to extract it from each one of the users. So it really depends on your needs. Let me show you another diagram that might be useful. When we look at relational versus non-relational databases, you can think of relational as each table has a blog post, a blog tag, a blog comment, and it links these tables to give you the blog information. Versus a non-relational that stores this entire blog post in an entry and has comments, tags, categories, and all other related data just in one single place. So what does MongoDB use to communicate? If we go back to our example here, we had SQL for relational databases such as Postgres. Well, MongoDB has its own what we call query language. And it is just the MongoDB query language. But they both aim to do the same thing. That is to communicate with the database, provide an easy way for the server to communicate with the database. And in this section, we're going to be talking about that. And we're going to finally connect the dots and show you the power of databases once they're connected to a server. I'll see you in the next one. Bye-bye. All right, so let's create a table. If you remember to go to our Postgres database, we simply write PSQL and then our database name, and we'll enter the database. And now we can communicate with it using SQL. Now let's create a table. How can we do that? Again, SQL comes with some language syntax that we can use. And to create a table, we can use something like this. We say create table, which is an SQL command. We enter a table name, followed by brackets. And then we say what we want the column 1 to say with the data type, column 2 with the data type, column 3 with the data type, and then ending it with semicolon. Let me just press enter and see what happens here. I get an error. Data type does not exist. And that is because data type is referring to what Postgres or our relational database knows. We have to say ahead of time what type of data column 1, column 2, and column 3 hold. If we go back to our Chrome browser, we see that for Postgres, we have a few data types that we can hold. String data types, numeric data types, and date and time data types. And each one of them have different things. For a numeric data type, we have integer, which is a 4-byte integer. We have big int, which allows for a bigger number. And all these different things, we have even money, which is currency value. And the reason we have to give this data type is because of the way databases work. They're optimized to make sure that as long as everything is the same in their column, they're able to work really, really fast to perform actions. In our case, let's use some of the most common ones. We can use text for the first column. So let's do that. I'm going to press the up arrow and get create table. I'm also going to name this table. Let's call it users. And column 1 will be name. Data type can be text. Column 2, we can say that is age. And data type for an age, well, if we look down here, we look at numeric types, we want to use something like small int, which is a 2-byte signed integer. It means that a max for a small int, if I go to small int max, we see that the max range is 32,762. Well, nobody's going to be that old, right? So we can use small int for now. Let's do that. I'm going to say age is small int. And finally, the third column will just have birthday. And birthday can be a date data type. And we can just have date. Let's press enter. And I get create table. Let's look at our PSQL here. I'm going to minimize this. And if I click refresh here, I see that we have users. Look at that. And we have columns for the table users, that is name, age, birthday. It tells us the type and the length. So now we have our table. Awesome. There's also a way to do it here. If we do \D, I get list of relations. And look at that. We have our users table and the owner, which is me. Very cool. There you go. We've created our first table. Now that we have this, we can start entering some information. And by the way, you might be asking, how many times do we run these commands? Well, ideally, once you create your database and it lives somewhere on a computer, somewhere in the world, you only run this once, right? You create a table of what you want your database to look like, and the rest is just filling in and inserting information and reading information off of it. So this is the command that we're going to set up when we create our own database to set up our schemas. And then after that, it will just run on its own and it will be able to communicate with the backend. It's going to be very fun. By the way, before we get into the next video, I want to show you one more command. We learned the /d shows us our tables. If I do /q, we exit out of here and we're back to the terminal. All right. I'll see you in the next one. Bye-bye. Welcome back. Let's go back into our database. We've just created our users table, but now we want to actually insert some information. How can we do that? Again, using SQL, we have the insert into command that we're able to insert into whichever table name we want. We're going to specify the column and then the values of each of those respective columns, and always ending in a semicolon. I also want to emphasize that with SQL, the capitalization is just a standard, but if I made this lowercase, it will still work. It's case insensitive. So looking at our database, we have name, age, and birthday. Let's insert something. We'll say that we want to insert into users. Column 1 will be name. And then we have age, birthday, And no, you don't have to insert every time into every column. You can just change the name if you want. All right, name will be Andre. Value will be 31. And then birthday we'll say is, if you remember the day syntax, if I open up here, is this, year, month, day. So I simply do 19. I'm going to make myself really old. We'll say January 25th. Press enter. I get insert. Awesome. If I do /D again, I see my table. But how can I see the value that I just entered? Well, first let's check here. Let's check with our GUI. Click on content, select users, and look at that. Name, age, birthday. I have Andre, 31, with my birthday. Very cool. Now, how can we grab this information? Again, a SQL syntax is select, and we want to say what we want to select. In our case, we can say name, age, birthday, from, and then the table name. In our case, users. Semicolon, press enter, and look at that. I get Andre, age 31, birthday. If I want to just grab the entire columns without spelling out everything, imagine if we had tons of columns, we can use the wildcard symbol of star. That's Shift 8 to get star, and I get the same thing. Very cool. By the way, with PSQL, we can actually run these queries here. See how it already has select? I can say select star from users, and it even gives me nice coloring. Press enter or press semicolon and run query. And look at that. It gives me the table for me. And it also has the history, which is really, really nice. Let's add a few more users here. I'm going to insert, this time, somebody else. I'm just going to change a few things. 41 and Sally. Inserted. If I select star from users, I have Andre and Sally. Going back here, run query, I have Andre and Sally in the database. How cool is that? All right, we know how to create a table, we know how to insert into a table, and we know how to grab this information. We can already start picturing what powers we can have now with our final project. But there's still a few more things we want to learn. For that, I'll see you in the next video. Bye-bye.
Okay, so let's discuss PHP a little bit. Keep in mind that our aim is not to learn how to code in PHP, so we're not really interested in all the details. We just want to see what is it used for and how we can recognize it, and also where can we find it. So first of all, what is PHP? Well, PHP is a programming language, or also can be considered to be a widely used open source scripting language, and its main purpose is for web development. Another interesting thing for us is that, as it says right here, PHP can be embedded into HTML. What does this mean? Well, the same way that we can add JavaScript inside of HTML, we can do it with PHP too. A simple example would be the code that we can see at this page. As we can see, the code starts with open HTML tags. We got some HTML open headers, open head tags, open body tags, and inside of the body tag, we get PHP code, which is embedded inside of this HTML code. This is the most simple PHP code, but we can notice what actually distinguishes it and what allows us to notice that this indeed is a PHP code. First of all, it starts with these tags. We got this arrow pointing to the left, then we got question mark, and then PHP. This is opening tag for PHP script. Under that comes the code, that we write in PHP, and in this case it is just a simple echo script that says, "Hi, I'm a PHP script." After you finish typing all of your PHP code, you simply just close the tags by typing question mark and arrow to the right. And after that, you can simply just continue with your HTML code. Okay, so PHP is used for web development, same as JavaScript. It can be included in HTML code, same as JavaScript, so what is the difference? Well, JavaScript is used for client side, while PHP is used for server side. The key is that client can't really view PHP code that is being ran by server, taking into consideration, of course, that everything is set properly and not misconfigured. Perhaps this is better said here in this paragraph, right here. So, as it says, what distinguishes PHP from something like client-side JavaScript is that the code is executed on the server, generating HTML, which is then sent to the client. The client would receive the results of running that script, but would not know what the underlying code was. You can even configure your web server to process all your HTML files with PHP, and then there's really no way that users can tell what you have up your sleeve, meaning that they can figure out what code you have in PHP. Another reason why PHP is good is, besides it being available on all major operating systems, it is good in command line scripting and server-side scripting, which we mentioned already. Server-side scripting is the main field for PHP. However, for this, we need three different things, and that is, we need to have the PHP parser, we need to have a web server, and a web browser. And in this case, to run the PHP code, you can just have the web server running with a connected PHP installation. Then you can access the PHP program with a web browser. How it exactly runs is explained really good in this image right here, or in this diagram, however you want to call it. As we can see, these are labeled as steps. We go from the device, as it says user requests some website. It goes to the Apache web server or any web server whatsoever. Then it processes back to the PHP interpreter, which is step number 5. Then it sends back to Apache web server, and then the web server processes the page and sends it back to the user. Now, another thing worth mentioning is that you can make PHP run without any server or browser. You could run it with command line, with just the PHP parser, and it will still work. Okay, nonetheless, this is the basic principle behind PHP. We just mentioned what it was used for, where can we find it, and how can we recognize PHP code. What is important to remember? Well, it's important to remember that PHP is used for server-side, it is mainly used for web development, and PHP can be embedded into HTML code. And we can see how to do that right here with a simple PHP script. Awesome. Everything else that we might need we will cover as we go. For now, this will be enough, so that's about it, and I will see you guys in the next video.